Okay, we are given a square is inscribed in an equilateral triangle as shown. Find the ratio of area of the square to that of the triangle EFG. Okay, I'll use a very important formula here. It will help us to reduce the lines of solution, that is making it fast. Assuming a square is inscribed in a triangle of base E. I'm saying a triangle, not really equilateral, it could be any triangle, and the height H. The side of the square is related to the base and the height of the triangle as X is always EH over E plus H. I'll prove it later. So since we are asked to find the ratio of area of the square to that of the triangle, so we now have area of the square over area of the triangle. We know that area of a square is length square, that is x square. So we have EH plus E plus H squared divided by area of a triangle is half base times height. So what do you notice? There is EH squared, E plus H all squared divided by this. So EH, so we have 2, so I have 2 EH over E plus H all squared. Okay, based on the information we are given, they say the triangle is an equilateral triangle, and we know that that's the side and the height of an equilateral triangle are related. Yes, the height is always half of the base times root 3. Yes. Okay, you can see it in the diagram. Let me just add it. If you know, this is the height, it's always perpendicular. This is H, and here is 60, and this is half. From here to here is E over 2. So the height is always E over 2 times root 3 based on 30, 60, 90 triangle theory. So I'm saying that the height is E over 2 root 3 over E plus E over 2 root 3 all squared. So which is, this is 2, so I have E squared root 3. Coming to here, E is here, there is square. So if you factor E is now E square, so E square. So I'm left with root 3 over, what is left here is 1 plus root 3 over 2 squared, which is 1 plus 3 over 4 plus root 3. Yes, do you get the logic? E times E is E squared. There is E here, there is E. If you factor E, remember this square affects everything, so the E squares, and what we left inside is now 1 plus root 3 over 2 squared. And if you expand 1 plus root 3 over 2 squared, you get this. Why the E squared will cancel out in both. So that's what we are left with, which is now 4 times that, 4 root 3, 4 times 1, 4 times 3 over 4 is 3, 4 plus 3 is 7, plus 4 times that is 4 root 3. So that's our answer. The answer is 4 root 3 is to 7 plus 4 root 3, which is option A. So let me prove how this formula X is equal to EH over E plus H, because that's the major thing. That's what made the equation to be very easy to solve. So let's prove that. even this, so it's the same thing as the formal diagram, just we use the alphabet as letters to represent the sides. So we're going to use similar triangles. So let's get the height of this small triangle, because this is a square. Let's call the side of the square x. So here is x, here is also x. So we have two similar triangles. So if we join the heights, like we get the height, we see that from here to here is x, because it's a square, while here is now h minus x. So using similar triangle theorem, we have that h minus x over h, that's this one over the long one, h, will be equal to x over e. That's by similar triangle theorem. Because triangle E, that's because triangle EAB is similar to triangle EFG. That's this small triangle is similar to the big one. So let's open up, let's simplify. This is 1 minus x over h. We have x over e. So our main aim is to get the side, which is x, in terms of h and e. Okay, so we collect like terms. We have, this goes over, so we have with 1 here. So x over e plus x over h. And if we factor x, we have 1 over e plus 1 over h. So which is, if you simplify this, we have eh, while here is e plus h, 1. So making x the subject of formula, therefore x is now eh over e plus h. So that's it. That's how we got the formula. That's the side. Once a square is inscribed in a triangle, you are given the height of the big triangle and the base. So it's just the product of the height and the base over their sum.